Yeah, how was that? Previous teacher that will solve one type of problem, which is wonderful if life was restricted to one type of problem. Unfortunately, life is riddled with not one type of choice, but infinite types of choice. So when you learn something that will get you through one question in a math class, but has no application anywhere else, it can be a little frustrating to you because you feel you know what you are doing because you can solve that particular type of problem for which you have been given a shortcut. Then you are faced with other problems and you realize, wait a minute, nobody actually showed me the way to do this, but I thought I knew. So that's what we're going to talk about right now today, because all of you can all read that first word problem, which is indeed a word problem. And recently I was informed by a class much like your own that they had a previous teacher that taught them a way to solve this problem. It's something I've never seen before and something, quite frankly, I've never chosen to see again because it was only good for solving these missing number problems. Now, does that seem like a real life problem? Not really. But you can apply the principles needed to solve that to a real life problem, such as, I have $20, I want to go to the movie, I want to get some froyo, and I want to get home on the bus. Okay? So let's go. We're going to do this first one all the way through. We are going to write all of the steps needed for that first one, and then we are going to slowly work through the next three. Why am I only going to do 4 practice ones with you? The same reason I should be able to do only 4 practice ones of anything with you. Because what is math but a series of patterns? Right? At our level. I mean, let's be honest. There are people working on mathematical problems much beyond our abilities. And there are indeed things in math that have no discernible nor identifiable pattern. However, at our level, math is always a pattern. So, we are going to look at all 3 of these things, 3 of these things, and then we're going to move on. In red, I'm going to do the first one. This is the biggest problem kids find with word problems. They don't know what they're looking for. It's like a paragraph of words. I don't know what I'm looking for. Where do you find what you seek? If I ask you a question and I continue to talk like I am right now, have I once asked you yet what it is you are seeking? No. Where do you find what you're looking for? At the end of your information, right? That's where it lives. So read the whole thing and find the question, right? Because a question is what is in need of a solution. The question lives often at the end of all the writing. Now, weirdly, in word problems, it is not always a question mark, right? Because in this very first one, it ends with the sentence, find the numbers. Okay, are we looking for kittens? Are we looking for slices of pizza? Are we looking for buried treasure like pirates? No, we're looking for 2 numbers. That's it. So this first thing is to identify what it is we seek. We simply seek 2 numbers. Are those numbers the same? No. All we're looking for is 2 numbers. Now the next part is something my grade 10 teacher made us do, and it really bothered me, but it helped. Write let statements to identify your variables accordingly. Well, that's a $5 word $5 sentence to say this simple concept. I seek one number. I seek a second number. I am using two different colors. Since I do not know the first number, what do I need to give it in math class? A variable, because it could be any one of an infinite series of numbers, yes? What variable would you like to give it? You always say x. That's okay. Which means, what must the second number be? Y. Done. Now, when I was in grade 10, we actually had to write, let the first number equal x. And then let the second number equal... Write it or don't. I don't care. But understand that you have two different numbers. That's it. Step 2. Write some equations. I have two variables, so I have to write two equations. What if I had 3 variables? What if I had 4 variables? What if I had 27 variables? 27 equations. The hint here, often every sentence gives me an equation. Is that a sentence?
It'll light up.
We'll wait.
We'll wait.
Anyways, I highlighted the first sentence. Is it a sentence? Does it talk about math? Where in that sentence does it talk about math? What? Oh, nice. It really crapped out on us. Where in that first sentence is the mathy word? Sum. I only have 4 options at our level of math. What are they? Addition, subtraction, multiplication, and division. What one of those 4 options is in use here? Addition. So the sum of the two numbers is 176. X plus y equals 176. There is another sentence. What does it tell me? X minus y equals 48. Now I have a system, and now I solve it. What method would be best here? Would it be graphing? Would it be graphing? No. Of course not. So elimination or substitution. I would use elimination here. Why, Jewel?
You have a negative y and a positive y.
Exactly. So I would add those. 2x equals 224. What does x equal? 112. Now what do I do with that? Put it back in the other equation. Does it matter which other equation? Of course not. You will find that y equals 64. And that is all there is to every single word problem ever. Decide what you're looking for, write an equation, solve the equation. Everybody makes a big deal out of them. Everybody gets all up in arms about it. But I would submit, pay attention to the words that apply to math. And you will never go wrong. So, the second question. What is it that I seek? I seek the price of a chocolate bar. I seek the price of a pop. Do I know the price of the chocolate bar? No. So since it's unknown, what do? I give it a variable. What variable shall I give it? So boring. Always with X. C. Chocolate bar. Do I know the price of the pop? So what do I give it? And what variable shall I give it? P. Now, seek out mathy words. Where do you see mathy words? What is the language of mathematics? Numbers. Do you see any numbers? I do. I see four chocolate bars. Well, that would be, if we were to write it in longhand, that would be C, 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 C. We don't write it that way because we're mathematicians. What is the shortcut to writing the same thing 4 times? Three pops. PPP. Equals 5.3. Do I need that 0? No. Do you all still punch that 0 into your calculator? Yes. I don't know why. But go ahead. I don't care. 2 chocolate bars. What do I write there? 2C plus 1 pop. P equals. What would be a good version to use here? I would do substitution because P equals 2.2 minus 2C. And then I would solve. Go diddly-o. And when you're done this system, you will see how old these notes are when you see how cheap the pop and the chocolate bar is. Now, let me ask you a question before we go on. How, if these are this easy, how is it that we have difficulty with word problems in the textbook? I will tell you my guess. Word problems in the textbook are intentionally obfuscated by extraneous words. Right? What? I don't know what any of those words mean. You're right, because I am obfuscating what I am saying with extraneous words and circumlocution. I find it very interesting that the word for putting in stupid extra words is a word that is a stupid extra word, like circumlocution. What I am actually saying is this. When you read a textbook word problem, they tell you a story. And it is confuzzling. Don't be confuzzled. What have I done with these two examples? I have boiled it down to the math. This question number 2, if you found it in a textbook, it would be this. Jehoshaphat lives in Flin Flon, Manitoba. He has to ride his bike 12 kilometers to get to the local Circle K in order to buy a pop and a chocolate bar. But since he doesn't want to ride 12 kilometers without knowing how many chocolate bars and pops he can buy, he checks the local Circle K flyer and finds out that there's a special on, right? You've all read word problems like that. And what is the reason it's difficult? Because of all the garbage. What is the only thing that matters? The numbers that apply to his situation. Not the fact he lives 12 kilometers from the Circle K, because they will do that to you as well, right? That is why the first step of today's work, what are you actually looking for, is key to cutting out the garbage. Just like in real life. Does it matter that you can get a free turkey at Walmart if you spend $100 when you're trying to go see a movie at High Street? No. So don't pay attention to the garbage in the question that has nothing to do with what you seek. Okay? Okay. Let's go on to the third question. And I'm going to take a step back and ask you to set up the system. Go. All right. What are the two things we seek? Startup fee and monthly fee. So I have two unknowns, so I need how many letters? 2. What would be good letters to use? Doesn't matter at all. But you can use, you want to use S for startup and M for monthly? Sure. What if I said I wanted to use Q and J? Would it matter? No. Startup equals S. Monthly equals M. Now, write your system. After 1 month, Jen has paid $260. How many startup fees has she paid? 1. S. Plus how many monthly fees? 1, because it's been 1 month, equals how much? Then, after 6 months, she has paid how many startup fees? 1. Plus how many monthly fees? 6M equals... You should be able to solve that in your sleep, right? Substitution or elimination? Okay. Go. Notice that I did neither the substitution the way I showed you, nor did I do elimination. I did that third one that I showed you when we had 4x equaled, or 4x plus 7 equaled 28, and 4x minus 9 equaled 32, or some crap like that. And I saw I had the same thing in both. So I rearranged the equation, so S was that and S was that. If S equals that and S equals that, what do I know about those two? They're the same. So I used that method. It's kind of like substitution and elimination mixed together, yes? Why would I do that to you? Just 'cause. You already know how to do it. I just wanted to show you a move that you can use later on in life. And all of you, of course, got the right answer, yes? Okay. Number 4 is this is the first one that's honestly a little bit tricky. But again, if we follow what we know, we should be okay. What has happened in this question? Nick has done something. What has he done? He has invested some money. How many amounts of money has he invested? Yes, but he has done something with that 2,000. He has invested it how? He has split it. So he has made 2 investments, hasn't he? He has made investment 1, and he has made investment 2. Do we know how much money he invested? We know how much money he invested in total. In my wallet right now, I have $20, Jordy. What denominations of bills do I have? In my wallet right now, I have $20. What denominations of bills do I have? You think I have one $20 bill? I know. I could have 2 10s. I could have a 10 and 2 5s. I could have 4 5s. If I was in America, I could have 10 $2 bills. I could have 21 $1 bills. So I'll ask again. Do you know how much money he invested? No. You know it totaled 2,000, but you have no idea what denominations. So what are your unknowns? How much went where? Yes? So how much went to investment 1? No. No. You don't know. So what do you give it? How much went to investment 2? You don't know. How much did he invest? So what equation can you write right now? Now, when you make an investment, you make interest, yes? Interest is a fraction of what you invested. Agreed? Well, what fraction did he make on one of his investments? 8%, yes? Okay, how do I write that as a number I can use? 0.08, right? Of one of his investments. Do you know which one? So, what do you write? Did his other investment make money? Yes, it made 10%. So is he making more or less money? More. So what math goes here? How much? 0.1. I'm going to put the 0 even though we don't need it, and you'll see why in a moment. And what did that make him? 190. Is that solvable? Why does it bother you? Are we allowed to multiply equations in a system to make them look prettier and easier to work with? Because it doesn't change the value, does it? What would you multiply this by to make it prettier? 10? 100. And what would you get now? 8x plus 10y equals 19,000. Now, can you solve that? Of course you can. What are you going to do right there? Substitution. Because x equals 2,000 minus y, right? Go. When you feel you have an answer, be the baby shark. Dun, 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 dun. Oh, speaking of baby things, we got a kitten on the weekend. A kitten. Minu. Minu. She is very cute. She is mostly white with a little bit of calico on her face and then like a calico patch on her right haunch. Yes. Yeah. I don't really get it. My wife used to have a cat named Manu, which was short for Emmanuel, because she got it at Christmas. Apparently it's some Christian thing that I don't get. And this cat is a girl cat, so she named it Minu, because that is like a feminine version. And my wife speaks French, and my daughter's in French immersion. And we used to have a friend that called her cat always Pouve Toi Minou because she was from Quebec. I don't really get it all. I don't really care. It's not my cat, so I didn't get to name it. I give human names to pets. Anyways, what's the answer? What is the answer? 1,500 and 500, yes? Except you haven't answered the question, have you? Because the way I set up this question, y was the 10%, yes? So, how much do you invest at each rate? Answer the question. 1,500 at 10% and 500 at 8%. Would I ever say you were wrong if you forgot that?
No. We're guessing yes, but we're also guessing no. I don't think so. I'd say yes.
Questions out of 4. You didn't write the stuff on the right. What do I give you?
3.
A B?
A 3. 3.5.
3.5. Because you did 2 out of 4? What am I, that teacher from the Another Brick in the Wall song? No. Some of you don't get that reference. Some of you do. If you don't get that reference, go home and listen to Pink Floyd, The Wall. The whole album, not just the We Don't Need No Education song, which is the only part any of you listen to because you think that that's what it means. It's not. All right, is everybody good? Please say yes, because I got to pee. Excellent. Start your work. It starts on page 203. Please notice how much garbage is. Look at how long that question is. Go.